Hello everyone, welcome back to my YouTube channel. My name is Lata. I'm currently studying my third semester BA in Sri Venkateshwara College of Engineering in the Department of CSE Data Science. And today's topic is about Way ANOVA in mathematics. And this is that contains first introduction to Way ANOVA, assumption of Way ANOVA, hypothesis of Way ANOVA, sum of squares in Way ANOVA, degrees of freedom in Way ANOVA, and F statistics in Way ANOVA, calculating the p-value in Way ANOVA, interpreting the Way ANOVA results, limitations of Way ANOVA, when we will look into the examples of Way ANOVA, and lastly conclusion. Let us see one by one. First, when we move on to the introduction to Way ANOVA. Way ANOVA is a statistical method used to compare means of three or more groups. It determines whether there are a significant difference between the means of the groups. And Way ANOVA is used when we have one independent variable with three or more levels. And this is a formula for Way ANOVA. F statistics or F ratio. F is equals to MSB divided by MSW. In this formula, F denotes the coefficient of ANOVA and MSB is equals to mean sum of squares between the groups, and MSW denotes the mean sum of squares within groups. And when we look into the assumptions of Way ANOVA, the populations from which the samples are drawn should be normally distributed. The variances of the population should be equal, and the observation within each group should be independent. This is also some of assumption of Way ANOVA. It compares means of independent groups, preferable when there are three or more groups of data. It should be contain one independent variable and one dependent variable. The independent variable should have three or more levels. Uses F distribution for calculation. Hypothesis in Way ANOVA. Null hypothesis, it denoted by H0. There are no significant difference between the means of the groups. Alternative hypothesis, and it is denoted by HA. At least one group mean is significantly different from the others. Sum of squares in Way ANOVA. Total sum of square, and in short form SST. The total variation in the data between group sum of square, and in shortly SSB. It variation attributed to difference between the group means within group sum of square, and in short form SSW. Variations attributed to differences within each group. Degrees of freedom in Way ANOVA. Total degrees of freedom, and it denoted by DFT. Number of observation minus 1. DFT is equals to n minus 1. Between group degree of freedom, and it denoted by DFB. The number of groups minus 1. DFB is equals to k minus 1. Within group degree of freedom, DFW, and it is calculated by total degrees of freedom minus between group degree of freedom. DFW is equals to DFT minus DFB. F statistics in Way ANOVA. The F statistics is calculated as the ratio of between groups means square to within groups mean square. F is equals to, and this is a formula for F statistics in Way ANOVA. F is equals to SSB divided by FSB divided by DFB whole divided by SSW divided by DFW. If the F statistics is significantly larger than 1, we reject the null hypothesis. Calculating the p-value in Way ANOVA. The p-value is the probability of observing a test statistics as extreme as the one calculated. Assuming the null hypothesis is true, it indicates the strength of evidence against the null hypothesis. If the p-value is smaller than the significance level, usually it denoted by 0.05, we reject the null hypothesis. Let us move on to the interpreting the one-way ANOVA results. If the null hypothesis is rejected, it means there is at least one group mean significantly different from the others. Post hoc tests such as Tukey's HSD or Bonferroni can be performed to determine which specific group differ from each other. Effect size measures like theta square or omega square can be calculated to assess the magnitude of those differences. Limitations of one-way ANOVA. One-way ANOVA assumes equal variances across the groups, which may not always hold the truth. A violation of the normality assumption can impact the validity of the results. One-way ANOVA does not provide information about the directions of the difference between the groups. One-way ANOVA example. When we look into the example of one-way ANOVA, example of one-way ANOVA include using to determine whether weight loss is best achieved through diet type 1, diet type 2 or diet type 3. That dependent variable would be weight loss measured in kilogram, and the independent variable would be diet type, which has three groups or levels. That is diet type 1, diet type 2 and diet type 3. In conclusion, one-way ANOVA is a powerful statistical tool for comparing means of three or more groups. It helps us determine if there are significant difference between the group means. By understanding the assumption, hypothesis and interpretation of the results, we can make informed decision based on the analysis. And thank you for watching.